All right, all right. And we are back after a long break due to various events. I am back from my first time teaching with Sans, which was super fun a couple weeks ago, and then we just had San Diego Comic Con here in San Diego last weekend. So I was there for the weekend, and I didn't want to go a whole nother week without streaming anything, so here we are on a off Tuesday night for some random reason. But I was so excited about getting to do Aragog that I just really didn't want to wait a whole nother week. So here we are. It's good to be back. I'm excited. I've got activity on YouTube and Twitch. Mixer is lagging behind, but I'm sure Mixer will catch up eventually. Let's just jump right in it. So today we're doing Aragog, and I did Aragog 2 months ago. So I have solved this before, but it's been a little while, and considering I can't remember what I had for lunch yesterday, we're still going to kind of stumble through Aragog and see how things go. I remember roughly kind of how the flow of the machine is, but the specifics of it are a little foggy. So let's check this out. And so it's a medium difficulty box. We generally tackle the easier ones on the stream, but I think this one will be fun. I think people will get a lot out of it. So let's grab this IP address, and we'll go ahead and do our nmap-p-. I'll put this to full TCP. What we've already done before the stream is I have my OpenVPN set up already, so my VPN connection to HackTheBox, and then as usual I have my own directory set up specifically for the box. So we'll output all the different outputs of the tool to files so we can reference them later if need be. And we're going to just assume that there's a port 80 open because, you know, it's HackTheBox and generally there is, and we can get multiple tools going at the same time. So there does seem to be a, it looks like a default Ubuntu page. Just kind of scrolling by, I see, you know, Ubuntu's Apache 2 default configuration is kind of a big giveaway. But so we can just open it up here in our web browser. Okay. And we've got burp running in the background, so, you know, we can get that sweet proxy history going. Since we know that there's a web server while Nmap's running, we can go ahead and start running a directory brute forcing tool, as is common, very common in HackTheBox. I've been using dir search lately. I loved GoBuster, but it just seemed to be fairly inconsistent. Like it would miss some results or something. And I don't, maybe it's something that I was doing. I'm not sure. But dir search I've been having a lot of great luck with lately, and not that I have needed this, but it's written in Python, so if I needed to go in and tweak it a little bit, I'd be able to do that. So we're going to use U to set which URL we're going to, and we'll do W to set our word list, and we're going to use the dirbuster, use the directory 2.3 small. I usually use the medium, but what I've been finding is that it's not really been needed in most HackTheBox machines. What I'll generally do when I'm actually solving the machine ahead of time is I'll run small first, and then if it doesn't catch anything, I'll let medium run against it. There are some much bigger word lists that I've also had success with, but in general, for things like HackTheBox, you don't necessarily need them. If you're brute forcing against a machine, maybe, but even, I don't know. To be honest, I've never used a tool like this in a live engagement, just because they're so noisy. But anyway, so dir search needs extensions. So we can see here It looks like a normal Apache server. We can do some guessing. Let's see here. So definitely we'll use HTML. It mentions PHP, so maybe we'll do PHP. PHP is pretty common in Linux Apache servers, so we'll throw that in there. So we'll do HTML and we'll do PHP. Excuse me. And that should be good enough for now. And then we'll use T for number of threads. And since we're on VIP, we'll do 50. It's not a live machine. It's retired. It's not new, so there's probably not a lot of people hammering at it. You want to use discretion when you're using T, though, as we commonly point out. There's another thing that I want to do. The output flag is a little funky in dir search, so I have to refer back to it occasionally. So it's going to be plain text report is the one that I want. We don't need anything crazy. Here we don't need like a JSON report, though that is super handy if we're doing some scripting or something against it. And we'll just call this dir search .out or something, and we'll let that run. And it's going to go crazy here. You see the thing spin up, and there it goes. I don't see it doing the extensions. Can do a -F to force the extensions on it. There we go. So we got an index.html, a .php. What the hell is that? We see that on our nmap we have a port 21, 22, and 80. So we'll go ahead and spin up our service scan / default scripts scan as well. So 10.10.10.78. And we'll do a -A, which is service detection, version detection, default safe scripts, etc., etc., etc. And then we'll -O for output all to, let's see, we'll do, I usually call it like TCP-scripts. I label it like this specifically because if we don't find anything or we don't find anything useful, or we're not able to get a foothold on the box, then I might come back and do some UDP nmap scanning. And UDP nmap is pretty rough unless you know for a fact there's UDP services running, just because of the way the UDP scans work. But it's important that you don't forget those when you're doing recon, especially in real environments where they might have UDP services running. You don't see it as much in Hack the Box, but they definitely exist. And we can see already, and this is why I like to have multiple tools running at the same time. While this is running here, we already see that there's a host.php, which is interesting. These like .html and .php are forbidden, so probably can't do much there. But this host.php is interesting. And we'll take a look at this. So we're able to anonymously connect to FTP, and there's a test.txt file there. That's probably worth checking out. Additionally, we've got some information about the SSH server that's running, and then we already know that the Apache server is the default Apache. But let's check out this. Let's check out this port 21 that's open here. What's the IP address again? 78. And we'll do anonymous ls, and we'll get that test.txt. Download that. Thank you very much. FTP is a very polite protocol, so we use bye to leave instead of exit, which is rude. And so we'll cat test.txt. So we see this interesting file here that's like details subnet mask test. Okay. This looks like it could be HTML or some other sort of markup language, maybe. The other thing that it could be, I have an eggplant macro tied to one of my macro keys, and sometimes I hit it because it's like right next to shift. So we'll and it's for Slack and Discord and stuff. But this is an interesting looking file, and hopefully we'll be able to figure out what this means in a little bit. But right now, it looks like it's some kind of, I don't know, some kind of data. I would assume for like a web application, like it could be XML or something. So we'll come back here. dir search is still chugging away, but we'll take a look at that host.php. PHP may have been here before. And we've got an interesting, there are a crap ton of possible hosts for blank. And so that's interesting. If we check the source there, there's nothing. Okay, so it's really just outputting that. So that's interesting. What this says to me, being a former sysadmin, is that this, like, there are X number of possible hosts for blank. This looks like it's a subnet thing. Like we see a subnet here, we see number of possible hosts. That's very common for subnets. So like, let's take a look at is there an online subnet calculator? So we won't get super into like networking and subnetting and all that stuff, but it's important to know when you get into more than just hack the box, kind of how networks are laid out and how they're described by their network addresses. So the most common one we see internally, at least around our houses, is like this 192.168.0.1. And so this is a private IP address. It's not routable on the public internet. That's why you see it so much at home. And then you see the subnet mask. This is the default subnet mask for the 192.168.0.1, etc. The way this works is it looks better if you map it out in binary. Does this thing have it? Show it in binary? No? Okay. You can kind of see it here. If you see here, it's like N laid out all the way in the 3 octets, the first 3 octets. And that's designating that these are the network part of the IP address, and that's designated by this 255.255.255.0. Let's do a quick, let's do like a quick little, like, show you how this works. So like we'll do gedit or something. And so let's look at this. So the reason we call these octets is because these are 8-bit numbers. So what that means is that you can actually express this IP address or this IP address in binary. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Oop. Okay. So you can express IP addresses like this, right? So this would be 0, of course. If we did something like this, this is the exact same as 255.255.255.0. Okay. So when we say that this has a subnet mask of 255.255.255.0, and we say that these are the network addresses, that means that this is the subnet mask. That means that everything on this side of the IP address is the network. And then anything over here is the IP address, okay? And so you'll often see something like this expressed as a /24. And the reason for that is if you count up all of the ones on the left side of the address, there's 24 of them. There's 8 here, there's 8 here, there's 8 here, that's 24, okay? Again, we're not gonna go super deep into this. I'm just kind of explaining some of the common things that you hear, or like some of the phrases that you'll hear a lot. Anyways, so what this means is there are 8 bits on the right side that can be the hosts on the network. So again, this is the network address. This is the host or node address. And that means that in this particular address, there are 255, well, technically 253 possible hosts in this address. And that's because 8 bits can be 255 possible hosts, and then there's one host at the bottom that's used for the network address, and one host at the top, generally at the bottom and the top, that are used for the broadcast address. So 253 possible hosts. So I know this because, again, I used to be a Linux and like system and network admin, but maybe you haven't experienced this yet. But that's why when I see something like this, where it said, oh, there are this many possible hosts, and I see something like this, these don't actually match up if you do the math. But you see something like this with a subnet mask, and you see something else saying there are this many possible hosts, you're like, okay, this is some sort of web app that is calculating the hosts, the subnets and the hosts. What does this mean? Well, what this says to me is that somehow this web server, this web application, takes a file like this and calculates the subnet and the hosts available to that subnet. So, I'm sorry, Clever Remark points out that there can be 256 values because 0 is a possible value, and there's 254 possible hosts, which is actually absolutely correct. Thanks for pointing that out. So anyways, there's some way that this web application takes this input and does some sort of calculation. So my first guess would be that it's through this FTP server. However, as we pointed out, there are not like 4 billion possible hosts in 255, 255, 255, 192. So those don't match up very well. What is another way that we can get information into a web server? Well, there's like form, and if there's not a form available, maybe we can just post. Maybe we can just post to it. So let's see if we can send this to repeater. And instead of doing get, we're just going to change this to post. We hit go. Okay. Now, what if we post this? And see, now we see that it changes. There are 62 possible hosts for this subnet address. Okay, so we were able to infer that this data structure is being used to feed the calculations for this web application. Cool. So if we're supplying it what looks like XML, and it's processing and responding to that XML, it's probable that we have some sort of like XXE vulnerability here. So let's check out like the OWASP XXE page. Okay. So here's XXE. Essentially what this is that XML is a document description language where you can describe documents. In fact, if you look at like Office documents on the back end, there's a lot of XML there, just kind of describing the document and the layout of the document. Web servers used to use this a lot. Less so now. Now we use JSON a lot more, but web applications used to use this a lot, and they would take XML to do exactly what we're doing here, describe the information that the website needs to process to display or conduct its output. And if we're able to control that, if it's allowing us to do shenanigans, then we can control its output in very different ways. For instance, we can specify that we want to use a system entity and say, hey, we want you to output like stuff from random, which is, not very useful. But maybe output a file, or if we want to, possibly get some code execution going, maybe. So there are numerous different ways to exploit XXE, and not every system is vulnerable to all the different methods, but you know, it's a good place to start. And honestly, I'm not even actually, like I said, it's been a couple months since I've done this, so I'm not even sure if this is the right path for this box, but this is kind of the path that the experiment's taking me down. So the first thing we'll do is maybe we can like use the, since it's a PHP site, maybe we can use the remote code execution here. Nope. Let's go back and maybe we need to format it in here. So if we like, let's do, we'll put the XXE in the subnet mask range. That certainly did something. Oh, wait. Ugh. Yeah, this is not a technique that I use very often. So we'll see how long it takes to actually get this to work. So instead of doc type element foo, do. Can we do that here instead? Nope. In fact, it's not even like recognizing this right now. So Clever Remark says, "Oh, that's awfully prideful from Twitter. Hello, good to see you." Yeah, the large value is very specific, and my guess is that it would be for like my guess is that that's basically 0. In fact, 4 billion is definitely the 32-bit. So if we do like max unsigned 32-bit int, not that one, I said unsigned. I don't know why it like insists on giving me the signed value. Yeah. So if we look here, let's explain what the hell I'm talking about for just a second. So if we think about IP addresses in the way that I was describing them, which is that they are basically just 4 8-bit values. That means that there's 32 bits in this value. And what I mean by signed and unsigned is in a binary value. So like if we look at this, that might have been one too many. Yeah, that's one too many. Anyways, so what a signed or unsigned means is that if it's unsigned, if the value is unsigned, then it is assumed, the value is assumed to be a positive value. That is to say that you can put all of these ones together and you have a positive number. a signed value or signed integer means that the leftmost bit, the one that I have highlighted right here, controls whether it is positive or negative. Okay, so what happens is because you get rid of this bit, it basically gives you half the available number space. And so this number here, this 2,147,000,000, etc., is the available signed space, the positive area of an integer, whereas it can also be negative 2.1 billion. Since there is no negative IP addresses, they're unsigned, and so you can have 4.294 billion IP addresses, and if we notice, that's what it lines up. So this is just because we're not submitting any data to it, it doesn't have a subnet mask that it's calculating the hosts for, and so that's just the total possible IP addresses. So I still think it's a XXE thing. I just need to figure out like how to get that working. There's something in Twitch chat that I missed. So Cryptsec says, do you know about John Hammond? He has a complete list of Pico CTF and over-the-wire videos. It's a good resource for people like me. Cool. Well, yeah, I didn't know about John Hammond, but there are a lot of YouTubers and there are a lot of different YouTubers and Twitch streamers and stuff that cover this kind of stuff. So I'll certainly add them to the list. That's good to know. All right. So we're going to do, I'm trying to think here. Let's start with this. So there's instead of, you don't have to necessarily just do like file reads or expects. You can actually also have it reach out over the network. So just to even see if this is processing, I'm going to set up a Python web server. We'll check out our IP address, which is the 10.10.14.10. And if I recall correctly, it should just be something like this. This is really just a URL of some sort, and you can put in a file descriptor or a web descriptor or anything like that. So instead of doing the file, we'll do 14.10. We can actually get rid of this because we're not displaying anything. And so if we run this and I get pinged, if this actually tries to hit my web server, which we'll see the log here, then we are getting some sort of XXE execution. I just need to figure out how to get it to do what we want. Nope. Do I actually need I don't think we actually need this here. Oh, yep. Okay, cool. So we are definitely getting it. So now if we do the file, hey, okay, here's the XXE. Right on. Oh, I mentioned this a couple streams ago, and I don't think I've shown it yet. So I have my repeater set up to where if I control enter, it just sends the request that I want, which is really handy when I'm messing around and, you know, I'm like, okay, here's the thing, and just hit enter, and then I can move on and keep enumerating or keep working through the exploit. So if I recall correctly, that's in here. Yes. And then if you edit hotkeys, it's the one I use is called control enter, issue repeater request. So if you go into your burp settings, you can set that up as well. I love it. Some people may like it, some people may not. But if you're curious how I'm not like hitting my, hitting the go every time, then that's why. So, okay, so we're able to read files. So we might be able to do some other stuff as well. But right now we can check out the Etsy password, and we can just even grab the Etsy password. And we'll just put this into our notes. Password. And so we have a couple users here. So I've actually used this in interviews before. Like, we'll be hacking around on a box or something, and they'll dump Etsy password, and I'll ask them, I'm like, hey, how many users are on this box? And sometimes they can answer and sometimes they can't. So this may be something that we should go over. In Etsy password, these different fields that are separated by the colons mean different things. And we can kind of walk through and show you what they mean. The first one is the user name, like the actual name of the user. The second one is where we used to put password hashes. Or, I mean, just sometimes just straight passwords. But this is where the password hashes used to go. This is actually why it's called Etsy password, even though passwords aren't put there anymore. But if an X is there, that means go to the shadow file, go look for the shadow file. You can actually still put password hashes here and have them work. And in fact, a lot of embedded systems like IoT systems still put password hashes there. The next one is the UID. This is the ID number of the user. This is the GID, or the default group number of the user. This is just a name identifier. This is, like, here's the name of the daemon. You can also put different useful bits of information, like if you can put a phone number in there and stuff like that. But really, that doesn't need to be there. Like you can see for this user, it doesn't have anything in that field. The next one is the home directory of the user. So for root, it's root. For Cliff, it's home Cliff. And then this is the logon shell, or the logon application, the application that's ran when the user logs in. If you see something like user has been no login, or let's see here, or been false, that means that this user is not meant to log into the system. Okay, you can't actually gain like an interactive login through traditional means for this user. So when somebody asks you like how many users are on the system, it's usually fairly safe to assume that all of these users with bin false or no login are like service users or application users. Interactive users will generally have like binsh or ksh or zsh or whatever shell they like to use. So for this one, we can just quickly scan and we see there's a bin bash, there's a bin bash, and there's a bin bash. So there's 3 users or 2 other than root. So what does that mean? Well, let's go spelunking for a minute. We have read permissions, or we have read capabilities for some things. Let's see if there's like an Apache user or a dub-dub-data. Okay, so we're probably dub-dub-dub-data, but we can go spelunking a little bit. This is sort of like having a these are sort of like having like an LFI, like a local file include. You can think of it like that. So we can go looking around for stuff. So first things first, let's take a look at Linux, because everything is a file in Linux. There's a special file directory structure called proc. And proc is interesting because it doesn't actually exist on the file system. If you examine a Linux system's hard disk forensically, there won't be anything in proc. It is 100% in memory. And this is where all of the descriptions of all of the processes live. And so these are all process IDs that you see here. There's a special subdirectory in proc called self that just describes the running process. So if we look at this one on my local system, this is on me, I can do, I can go into proc self and I can do something like, let's see, like CMD line. And that's literally just showing like the command line for the application that I'm running. So if we do like catproc self, UID map, I believe what this is showing, and I'd have to look up the proc UID map. So if we look here, I believe this is showing that we're the user ID 0. Welcome to Dana Too Deep on Twitch, and then Infected Jesus and YouTube is asking about the Kali Linux fish. I'm not really sure what's going on there. So we had a GID map. Okay, yeah. So it does look like it's mapping the UID and GID. So let's see if we can do that on the other system. So we'll go proc self UID map. Okay, so it's definitely not showing the user ID and GID. All right. Well, so that's a dead end. Is there anything else useful that we can get there? Proc self environment. Wow. Yeah, that's actually going to give us a lot of good information if we can get that. Proc self environment. Nope. The problem is that not all of this exists or is accessible for every UID. Let's see here. Okay, that's fine. So can we also do, is it possible to do, now that we've got this running, to do the like the PHP command execution maybe? Nope. All right, fair enough. Let's see if we can. Let's see if we can. So also, when you do this file include method, when we were doing file like this was the this is like the let's see, the absolute path. So file : / is just like HTTP : / and then after that we do /etc/ password, right? So we're starting from the root, we're getting etc password. We don't actually have to use that file descriptor. We can actually just do a relative path as well. So we know that there's a host.php. So can we get that? No. Oh, come on. Come on. That's really disappointing. That is still working, right? I was really hoping that would work. Let's see. So we've got a host.php and index.html. Let's see, XXC. What kind of... Yeah, Ender's just asking if it's a coincidence the number in UID map and the number of possible hosts are just one off. Yeah, it's a coincidence. It's probably just likely a like a 32-bit number. Hmm. There is a really cool blog post that I saw a while back. Oh wait, XXE remote file include, is that a thing? Since I can get it to call out. Do. Come on. Of course it wouldn't be that easy, huh? Well, thanks for subscribing, Infected Jesus. I'm glad you're enjoying the stream. I don't remember getting stuck on this section when I came through it before. This is funny. It's amazing the kind of stuff you get tripped up on. Oh, that's another thing. Let's can I XXE like PHP wrappers? Huh. I wonder if this will let me. Ha! Awesome. No. That was dumb. Come on. Let's see. This was like a super roundabout way of doing this, but whatever. All right. Now we know what this does. So yeah, this is exactly what we thought it was going to be. Is it's taking an XML, processing it. It's pulling the mask from the details in the subnet mask, and then it does some operations on it, and then spits it out, right? And then interesting. All right. So if we can do that, is there other stuff that we found? We didn't find anything else, huh? What is that PHP? Like, Is that like a thing? Nope. Okay, cool. So we can do that at least. Yeah, I wonder, can we do that? Let's see here. Let's see. So if we do like I'm going to grab this handy dandy PHP reverse shell because I know that for some reason everybody hates Metasploit. We will unzip it here. And come up here and we look for our IP address. And we are 10.10, 14.10. That makes it easy. I'll just be 443 for the port. We're gonna move into the PHP reverse shell and we'll do Python 3m http.server. We'll set that up on port 80. And then we will set up a netcat listener for the reverse shell. We'll see if this works. I'm not convinced that it will quite yet, but if we do what's the name of that stupid listener? PHP reverse shell.php. Okay, so it certainly gets it. It just doesn't run it. It doesn't like. No, that would be too easy. Is it a... it's still not working. I wonder if I can get at the logs. I could definitely do some funky stuff there. Oh no, but we would need to be able to. We need to be able to include them. Roman 6 is asking if I can write and read to temp. I can probably read from temp, but I don't think I can write anywhere right now. Right now I just have local file include. I can't seem to write anything. So it's kind of where we're stuck at right now. One thing I guess I can do, since we know there's a couple users here, so let's go back here and check our password file. Just set this over here. Let's try. Where are these guys is like Home Cliff. .shdrsa maybe? Nope. Who's the other one? Florian? Hey, okay, cool. I didn't expect we'd be able to do that from www data, but sometimes you get lucky. So for those of you who didn't quite follow along with what just happened here, there are ways to do passwordless authentication for SSH using keys, like public keys and private keys. And the standard place, the default place for private keys, for SSH keys to go, is in the home directory .ssh, and then the default name of the private key is ID_RSA. That's not always true. I often name mine something different, just so I can keep track of them all, because it's not usually good to use the same private key everywhere. But also, you know, like for reasons like this, like, you know, somebody might not know what, you know, fluffybunny.priv is versus like ID_RSA. So this is something, if you get a local file include and you're kind of stuck and you're not getting much love, a lot of times people will kind of mess permissions for this up. Now what's cool is it's hard to mess this up in real life. SSH is really good about forcing good permissions on private keys, but unfortunately not here. So we can go ahead and do vi, and we'll do florian.priv. And then we'll SSH Florian at 10.10.10, was it 78? 8, and then we'll use the -i to specify an identity file, and we'll specify our florian.priv. Oops. See, and this is exactly what I'm talking about here. So if you use private keys, public and private keys in SSH, a lot of times SSH is smart enough to say, hey, the permissions on Florian are bad. You should make them a little more strict. So let's do an ls-al. We'll check out the permissions on florian.priv and see these privileges look probably a lot like what his privileges on the target box look like, which is we got read write for root, which is fine, and then read for the root group and for everyone else. And it's this everyone else that's the problem. We need to get rid of that. Generally speaking, I set mine to 600. And then if we do this again, we'll show you what 600 does. 600 just sets it to read write for owner. And then since it's 0, no one else gets permissions. No one in the group, and then no one that's everyone else. Okay. Now we SSH in, and we're Florian at Aragog. Groovy. So there was a question, Deception on Twitch was asking if we can check out the bash history, which it looks like we can. That's not common in Hack the Box. Typically in Hack the Box, they will chown the bash history to root so that the user can't write to it, so that the bash history is preserved as 0. And that's pretty common in like shared CTF boxes, because you don't want, other users to see what past competitors have done. But yeah, well, let's take a look at it. Okay, so it looks like they were looking at the Etsy password, tried to get to root, started looking at the groups, and then shut down the box, and then SU'd to root. So that was done by likely the person that was setting up the box, not like another hack the box competitor. But as often we do, we're just going to run sudo -l real quick to see if we can. And unfortunately, we don't have the user's password because we used a key to get into their account. That's unfortunate. But we do have the user here, the user flag there. So as usual, I won't actually cat that out, but we have achieved user so far. So that's pretty nice. So if we cat Etsy password again, we'll just take a look at it from here. We notice that there's us and then there's Cliff. And so we might not be able to escalate to root directly from Florian. We may have to privest to Cliff first, but we'll see. So we'll take a look. We'll start with the www data. Let's go check out this. And if you notice, there's a dev_wiki folder here. So let's check that out. So it's something that we didn't find earlier in our dir searching. This looks like a WordPress, like a default WordPress theme. So we'll just jump in here. And so we can do a lot of stuff from here, right? We can check out like the less wp config, and we should be able to find, yeah, here's the root password to the database. So we can run MySQL, like the MySQL client locally. Let's go ahead and do that. We'll just grab this. And we'll pop this in vi wp config truncated. And we'll MySQL U for user, and we'll use root, and P, and then we'll just, MySQL U for user, go into root, and then we'll just -P, and it'll ask us for the password. If you do, you can do a -P and then without a space immediately type in the password. Doing that is not a good idea from a security perspective because that puts the password in your history. So that's why a lot of people will do that -P and then type it in locally. So we'll show databases. And then we've got the normal schema databases, and then we've got this WP Wiki. So we can use WP Wiki. And then we'll show tables. And we will select star from WP users. And we have an administrator password here using a what looks like a WordPress PHP hash, or this $P generally shows that it's some sort of, it's like a PHP or WordPress or something hash here. So we'll copy this and put it into our notes. But if I remember correctly, that's not going to matter much, but we'll put it in here and we'll call this WP users.tv or .table. And just put that in there. If we don't have much help, or if we don't have much luck here, we can maybe crack this or something. Or generally, if this was an engagement, I'd throw it into like my password cracking station to see if it finished by the end of the engagement. If it did, then we can let the client know and say, hey, we crack some passwords, they might want to get them, change them. But if they don't get cracked, then nothing happens, right? We're just like, okay, whatever. They're at least strongly hashed or something like that. Roman 6 asks, reset something to something you know. That would be useful if we actually wanted to get admin on the WordPress server, but we might not need to do that for a couple reasons. One, it may not be pertinent to our goals here in the Hack the Box. We may not need it to get root. The other thing is I am really reticent of resetting passwords on an engagement. Even if it's only on a test environment, I generally don't like doing that. It's pretty destructive. It will 100% alert people to the fact that you're doing something nefarious. And on top of that, if it isn't a dev environment, or if you do that to a user that's actually using their account, you can lock them out of their account. Which will generally, piss off your clients. So I tend not to do that. Sometimes you need to in like a CTF or something, but I don't even see that tactic in a CTF a lot because it's not very scalable if there are many people in the environment, competing. So we'll leave it there for now. If we get stuck, we can reset it to something we know. But that's fine. Let's take a look at the site. This is something that I see a lot of people kind of blow past, and it's very important, even if it doesn't serve us well in this specific challenge. This is something that more people should be doing, is actually look and use the target to better understand how it works and what its function is and stuff like that. So we'll take a look. Again, this just looks like a normal WordPress site. Looks like default content so far. Okay, so Cliff says something. So thought we could use a wiki. Feel free to log in and have a poke around, but I'm messing about with a lot of changes. I'll probably be restoring the site from backup fairly frequently. I'll be logging in regularly and will email the wider team when I need some more testers. Okay, cool. That's interesting what he says here. I'll be logging in regularly. Even if they're not going to log in regularly, you can assume that an admin is going to eventually, right? So let's check something. Okay, so if we notice like the weird coloration on DevWiki, and we see here that it's set to essentially 777, which is it's read, write, execute for literally everyone. And like everything is 777. This means that anyone, not just Cliff, has read, write, execute to every single file on here. What's cool is if we can modify the code, then we can probably either intercept or shunt that password off to something else that we know, or something else that we control. So let's find out. Let's find out where the so WordPress login page code. Let's see. Trying to remember where this is. let's do this. Grep I for case insensitive, and then we'll do like let's do like password. I'll just do it anything. Whoa, that's a lot probably. So we expect it to be in WP login. If I remember correctly, that is not true. It's not in WP login. Activate's not correct. Whoa. WP includes. Should grep minus v for inverse .js. Can I do that though? Yeah, I probably can. Nope. Come on. Really? That's unfortunate. What is going on here? Like, there's something funky going on with the system. There we go. Okay. Maybe it is WP login. I feel like it's not, though. I think it's here. Okay, so WP includes user.php. So we will WP includes user.php. Authenticate and logs a user in. Ha! Perfect. This is exactly what we want. Okay. So WP sign on. And what we're looking for is what we want to do is if the user was successful, we want to just write it out to a file. We want to write out the password that was used. So it looks like here. It looks like here. Wait. Authenticate as a user with the remember capability. Okay, we don't want that. Authenticate a user confirming the username and password are valid. This is what we want. Okay, if empty username, if empty password, cool. If not user, error, blah. So if there's an error, So I'm looking for somewhere, like somewhere specifically, there's like the authentication. And I want to say that it probably has something to do with WP check password. I'm not seeing like a success here though, which is what's confusing me. Okay, authenticate email and password. So user get user. Oh, but wait. So this is being included by something. So like grep WP includes user.php R. You would think that this would be included by... Oh, wait. Is it here? I don't think this is it. So 7string Ninja said return $user equals success. And so that gave me the idea to start grepping for success. It looks like fires after the user has successfully logged in, but this is for cookies. So 7string Ninja clarifies, saying that return user is equivalent to success, and I think that might be true because that seems to be like at the. I kept looking for this, but maybe not. Maybe just returning the user is success. If user instance of WP user. What I'm curious about is where they're getting the password from. because that's what I need to find, not what's processing it, but I need to find, and maybe I can use where it's being processed, but I feel like I need ugh. Ugh. Ezekiel TBH is asking if they can help with the right function name. Please do. If you know the function name, by all means. Otherwise, you're going to be watching me like just grep through code forever. Oh my god! Like, what is the deal with this? Why does it keep messing up? WP sign on. Interesting. So grep I WP sign on. So it's in user.php. Cool. Oh, Mateus is asking what we're trying to do right now, log in the WP without the admin password. No, what we're attempting to do is find where the admin password is actually entered into the site, and then we're going to backdoor that page by stating that when a password is entered, do normal for sure, but also write out the entered password to a file that we can read. And that way we can get the administrator password. Assuming that that is Cliff's password and he's reusing it for his local account. And then we'll maybe then use his account for the Privesk. So here, okay. Oh, so here the user equals, and then these credentials. Let's do this. Oop. Oh my God, they're actually using VI. No, Vim. Oh God. Okay. That's like super awful. Twitch asks, don't you already have the MySQL root password? I do already have the MySQL root password, but that is not the same as Cliff's administrator password. So here we're going to just going to write a we're just going to write that variable directly to a temp file. We're going to call this temp foobar. We're going to write like this guy, right? So let's just write user. No. I'll just write this guy. Or can we write the whole damn array? Yeah, we won't get greedy. It's a good thing PHP doesn't care about indentations, huh? Oop. Oh, I know why this is happening. So every once in a while, like we'll be in the middle of something and it'll get mad because I'll be like, oh, I want to read this file or whatever. If you remember, in the blog, wherever the hell it went, there it goes. So this is going to be restoring from backups often. So there's some sort of scripted like cron. There's some sort of scripted cron task where he's restoring from backup, and that's like messing up like the path that we're in. Additionally, Twitch chat Calby0x004. I'm sorry if I butchered your name. It's asking it, so we could just reset the WordPress admin password, but what we're attempting to do is get the actual admin password, not reset it, but actually get it, because we're assuming that Cliff is reusing that password as his local user account. And so we're trying to pervesc into Cliff. So resetting the WordPress password doesn't actually help us achieve that goal. So we're going to cd back into devwiki, and we're going to edit this file. I'm going to come all the way down here. And put in our thing there, and then we're going to touch temp foobar. Right, it's foobar that we called that file. Yeah, cool. So let's go over to temp, and we'll just take a look at this. Foobar is tiny. Oh wait, we need a chmod 777 foobar. Hopefully we weren't too late on that. HTML dev wiki WP includes user. Okay, it's still there. Good. So what's going to happen is there's going to be some sort of cron that comes through, and you know, if this were a real box, what would happen is the admin would come in, he'd be like, he'd log in, he'd be like, oh crap, everything's ruined, and then like restore from backup. And then for some reason he does that exactly every 5 minutes or however long it takes. Here it's going to be a cron job, right? So the cron is going to come in, log into the website, and then reset the website from a backup. So we can do a grep for like a fingerprint in our code. So for instance, we have that my file equals temp foobar. We can grep for foobar in that to see if it's reset. It looks like it hasn't yet. We can also look and see if foobar size has changed, which it has. So we can cat foobar. And so we have this, which I'm going to hope is, see if we can go to like, is it wp-login.php? Nope. I always forget how, like, where that damn login page is. That doesn't really matter. Let's see if we can SU as Cliff. Nope. Said /wp-login.php. I thought that's what I did. Oh. Yeah, it was probably... Okay, so that is the login. Cool. Do. Do we have any unpublished stuff? Nope. Okay, so that's not it's not Cliff's. Is Cliff the root user? And Cliff is the root user. Okay, so there was a password reuse going on, but Cliff was reusing that password for root instead of his home user, which is kind of silly. But here we are, we're root, and we'll do that, and we can see that we're root. Let's cut the bash history on root. Let's see if there's anything funky happening here. Nope, just doing some network setup. So, not a big deal. But anyways, here we are. We've got root the root.txt. There's also the restore.sh, so we can take a look at that and see what's actually going on here. So yeah, it's just removing the wiki altogether and then restoring it from the ZZ backup here. Which would also have the wp-config.php and all that jazz that'll reset like the administrator account's password to get all this to work. So as you can see, it is good to not be super destructive when you're coming through these challenges, because if we would have just reset the password, I guess it's not a big deal because it had a cron like a script to restore it. But say they didn't have a script to restore it, we could have just like bummed ourselves out of being able to complete the box. So anyways, that's Aragog. I loved the privest to this. It's really unique. Having that kind of scripted user interaction is not common in our in like Hack the Box and other types of challenges. It's very common in Rasta Labs, which is nice, but in like these kind of quote unquote dumb boxes, not that they're silly boxes, but they're not intelligent. It's pretty rare. So I was happy to see that, and it was a neat little trick, you know, kind of backdooring the code so that you can get access to their account. It's much more finesse and elegance than just like brute forcing their password or resetting it or something like that. So anyways, thanks for joining me. I'm glad, again, like I said, I'm glad to be back. The next stream should be this weekend. I don't have a box picked out yet, but I'll figure something out, whether it's you know, some over the wire or you know, maybe a Vuln Hub, or we'll see what box is being retired on Hack the Box this weekend. But we'll definitely stream this weekend closer to our normal time in the middle of the day. So hopefully some other time zones can jump in. Anyways, thanks for joining me, and I hope everyone else had as much fun as I did, and we'll see you next time.